Assalamualaikum warahmatullahi wabarakatuh. To my viewers, especially my supervisor, which is Dr. Nordin bin Haji Sabli, my examiner, and also my final year project coordinator, which is Dr. Tina Idati binti Muhammad Ghazi. My name is Zikril Hakim bin Zulkifli with metric number 177792. Want to present my final year project with title The Study of Variation in Mass Ratio among Reactant Use and Ball Miler that causes significant difference in performance of nitrogen doped graphene as fuel cell ORR catalyst. My title have been changed from the previous presentation because of changing in parameter. However, my research background still the same, which is about graphene. What is graphene? Graphene is a pure carbon with 2D atom configuration. Graphene have single thin packed layer of carbon atom that bonded together in hexagonal honeycomb lattice, and graphene is extract from graphite. What is different from graphene and endographene is and nitrogen doped graphene is doping of the graphite with the source of the nitrogen, which is in this project the source of nitrogen is melamine. According to research paper, nitrogen doped graphene give a better conductivity compared to the conventional semiconductor. And for this project, the nitrogen doped graphene is synthesized by ball milling technique. What is ball mining technique? Ball mining technique is a mechanical nanomaterial synthesis method where no solvent is needed. What it means is the ball mining process is a physical reaction, and the process is so easy and inexpensive. And also the advantage of the ball mining, it can synthesize a large amount of product. uh, because of the change in title, so that's mean there is change in my problem statement. First of my problem statement is what factor would cause the significant difference in performance of nitrogen doped graphene that was produced in varying mass ratio among reactants powder and ball miler. What it mean is it the nitrogen doped graphene performance as a catalyst is affected by the mass ratio between the powder of reactant, which is graphite or melamine, or is it the performance is affected by the affected by the mass ratio of the powder reactant and the ball miler, which is the zirconium oxide ball miler. The second problem statement is how would be the performance of the nitrogen doped graphene produced as a fuel cell catalyst compared to the conventional platinum carbon catalyst. As we want to apply the nitrogen doped graphene as a catalyst in the fuel cell, which is as for now the fuel cell catalyst is the platinum carbon. So we want to know if the nitrogen doped graphene have a same par level of performance as the platinum carbon. The third problem statement that rise to conducted this research is uh, because of we using the ball milling technique, which of the diameter of the ball miler better in the synthesization of the nitrogen doped graphene? Is it the large ball which have a higher force impact during the ball milling, or is it the small ball that have a higher total surface area for the milling? As we have as the project have a three problem statement, thus it will come up with the three research objective, which is for the first one, the objective is to find the variation in term of mass ratio, reactant and ball miler, that causes the significance difference in performance of nitrogen doped graphene as catalyst in fuel cell. The second one is to study the quantity of melamine reduced to form the nitrogen doped graphene at different ball miler diameter by X-ray diffraction XRD analysis. And the last one is to characterize and compare conventional platinum carbon catalyst with the produced nitrogen doped graphene, which are produced in vary mass ratio among the reactants powder and also ball miler. To conduct the project for this title is we can divide it into three parts, which is synthesization of the nitrogen dot graphene by ball milling, characterization of the nitrogen dot graphene by three type of characterization, which is X-ray diffraction, TGA analysis, and cyclic voltammetry (CV). For the XRD and also TGA, the sample was sent to the Nuclear Agency Malaysia for the analysis. But for the CV, the characterization is do by the do by my own. And for the analysis, the ANOVA analysis method is conducted. For synthesization of the nitrogen dot graphene, 4 sample was made, which is sample 1 with 1 gram graphite plus 5 gram melamine plus 100 gram of zirconium ball miler with 20 millimeter diameter. The sample 2 is 0.5 gram graphite plus 5 gram melamine plus 100 gram of 20 millimeter zirconium oxide ball miler. The sample 3 is 1 gram graphite plus 10 gram melamine plus 100 gram of 20 millimeter zirconium oxide ball miler. And the last sample, sample 4, is 1 gram graphite plus 10 gram melamine plus 100 gram of 5 millimeter zirconium oxide ball miler. Okay, for each sample, it will place in the mill chamber, and then the mill chamber is placed in the planetary ball mill machine. Make sure to use the safety lock provided to prevent any accident. Then we set the time of milling for each cycle, which is 30 minutes and 10-minute rest. 10-minute rest. And we set the speed of the milling to 500 rotation per minute, and we start the milling for 100 cycle, which means we are milling for each sample for 50 hours. Once the 50 hours completed, take out the product from the mill chamber and use the brush to remove the stuck powder on the wall of the chamber and also on the ball surface. And for the CV analysis, first of all, we have to prepare the ink for the prepare the ink for uh, stick on the glass carbon working electrode. To prepare the ink, we need 5 milligram of the nitrogen doped graphene sample plus with 380 microliter ethanol and also plus with 95 microliter naphthalene solution. Then we sonicate the mixture of the powder and the solution for 45 minutes. Then the homogeneous solution will form, and taking 7 microliter of the homogeneous solution, we'll drop it on the glass carbon working electrode and let the ink to dry, the homogeneous solution to dry and stick on the glass. Then we set up all the wiring cable and electrode, which is working electrode, silver chloride reference electrode, and also platinum straight control electrode. After we set up all the wiring and the electrode, we bubbling the sulfuric acid electrolyte with nitrogen for 40 minutes. After the bubbling, we have to make sure there is no bubble in the connector tube because it will affect the result. And if there is a bubble, remove it by open the bulb valve and press the bulb to remove the air bubble in the tube. Then we set the rotating this electrode speed to 1000 rotation per minute and run the test mode for the 80 seconds. And lastly, we run for the CV analysis with range of voltage negative 0.2 voltage until 8 volt. We run for CV analysis with range of voltage negative 0.2 volt until 8 volt, and the reading speed at 100 microvolt per second. Next, we continue to result from the project. This is the result for the for result from the XRD. As we can see, there is 4 graph actually. The end of graphene 50-hour BIX is the nitrogen dot graphene for sample 3, which is the sample with 1 gram of graphite, 10 gram of melamine, and 100 gram of ball mylar, but at the 100 gram of ball mylar with size 20 millimeter. For the second one is the graph for the melamine powder. The third one is the graph for the graphite powder, and the fourth one, the bottom one, is the nitrogen dot graphene for the sample 4, which is have a same ratio as the sample 3, which is produced by 1 gram of graphite, 10 gram of melamine, 100 gram of ball mylar, but the size of the ball mylar is 5 millimeter. Initial characterization of melamine and graphite, peak to theta at 226 degree is above 40,000 and 80,000 respectively. The nitrogen dot graphene that produced have a similar pattern of peak as the melamine. This indicate that the melamine is not 100% converted, thus it overshadow the graph for the nitrogen dot graphene. However, the melamine is reduced as turn to endographene, which is initially from which is initially the peak is from 80,000 plus to 30,000 plus for the 5 millimeter Bose Myler and 15,000 plus for 20 millimeter Bose Myler. So, to justify there is graphene, endographene in our product, the TGA analysis is conducted. First, initially we will run for the graphite. We heat until 900 degrees Celsius, but it seems that graphite does not reduce until 900 degrees Celsius. Then we run for the nitrogen dot graphene. Until 900 degrees Celsius and have a reduced elements from the graph, which is as we know, the melamine will melted at 345 degrees Celsius. Thus, as we can see, from the 300 degrees Celsius until 375 degrees Celsius, there's decline in graph that show that the melamine is completely burned. Then we can see there is a steady horizontal graph from 400 until 625 degrees Celsius, and then it suddenly dropped from 650 until 710 degrees Celsius. As we know, as the melamine have been removed, which is completely burned at the 375 degrees Celsius, it means that in the powder only left nitrogen dot graphene and graphite. So as we have initially conducted the graphite powder only on TGA, which is the graphite powder does not reduce even though have been heated until 900 degrees Celsius. It means that from the 650 until 725 actually is a burn nitrogen dot graphene. And as we can see, after 725, the stable straight line horizontal graph is produced. It means that only graphite left. So it's clearly shown that there is nitrogen dot graphene is produced. And this is the result for the cyclic voltammetry. And we compare for the four sample, and from the 4 sample, it's shown that the sample 2 with ratio 0.55 100, which is 0.5 gram of graphite, 5 gram of melamine, and 100 gram of the and 100 gram of the and 100 gram of the ball miler, have a best result for the ORR. And we also compared the result with the conventional platinum carbon, and we can conclude that the nitrogen dope graphene have a potential as catalyst, but the performance is far away to be compared with the conventional platinum carbon catalyst. Next, I will proceed to the ANOVA analysis. The aim of ANOVA analysis is to find the value of the F, so we can know if the F is within the range of the F critical or above the range of F critical. So, to make this ANOVA analysis, two hypothesis is created, which is null hypothesis that claim the ORR peak value means are equal. Meanwhile, for the alternate hypothesis, will claim the opposite, which is there is two population difference at least. So, from the calculation of the ANOVA, the F value for the column and also for the row, which is for the cycle of the reading, and for the sample produced, both sample produced, the value of the F is less from their critical value respectively. So it means that the null hypothesis accepted where all of the means value actually equals. Then the analysis is proceed to the Tukey's method, where from the Tukey's method, it shows that from the Tukey's method, initially I let the 0.5 ratio with 20 millimeter Bose Myler as a sample 1, and 1/500 ratio endographene with 20 millimeter Bose Myler as a sample 2, and 1/1000 ratio with 20 millimeter Bose Myler as a sample 3, and 1/1000 with 5 millimeter ball miler as a sample 4. This was made for easy for us to compare after this. And if we can see, actually sample 1, the 0.5500 ratio is equal to 1/10 ratio. So in order to make all the graphite have a same ratio, so I will recognize the sample 1 as a 1/10 ratio for easy the explanation of comparing. And from the Tukey's method calculation, only sample 1 and 3 that have a difference significance. It means that as we can see from this table of relationship, that sample 1 and 3 only have difference in mass of ball of Myler used. So it means that the nitrogen dope graphene that produced by using the ball milling have a significant effect if there is different mass of the ball miler used. So it means that the significant factor for the nitrogen dope graphene produced by the ball milling method that affect its performance is the mass of the ball miler. As we can see that the sample 1 used 200 gram of the ball miler mass ratio. Meanwhile, for sample 3 is 100 gram of ball miler ratio, and both of the sample have the same mass ratio for melamine and graphite, and also size of the ball also same. So that means the significant factor is the mass ratio of the ball miler. So as a conclusion, 20 millimeter ball miler have a better doping process for synthesization of nitrogen dope graphene compared to 5 millimeter. So bigger diameter of ball miler able to reduce more quantity of reactant. The second conclusion is high mass ratio of ball miler used toward the mass ratio of powder will give better result on end-dope graphene performance as electrocatalyst. As we can know from the analysis, it means that the sample 1 have a highest mass ratio of ball miler, so it give a best result of the end-dope graphene performance. And as from the ANOVA analysis also, we know that the main factor that give a significant impact on nitrogen dope graphene performance as electrocatalyst is the mass ratio of the ball miler. And throughout the project, there is a lot of recommendation can be found to improve the quality of project, and also to run the project more efficiently. First is to mash the powder before the sonication in preparation of ink catalyst for characterization. This is shown as in result of the CV that the sample 4 have a better ORR value compared to sample 3, because of sample 4 is more finer due to using a small ball of size. Therefore, the absorption of the ink on the glass carbon electrode uh, also better, that give a more sensitive result. So it's recommend to match the powder before we syndicate. Then because of the unreacted melamine overshadowed the graph of the endographene on SRD analysis, it is recommended to heat the endographene until 400 degrees Celsius so we can eliminate all of the unreacted melamine. Then the third recommendation is to use the harder ball miler for increasing the conversion of the production of endographene. As actually in the research paper, they use the stainless steel ball miler, so they will give more better production of the endographene compared to this zirconium oxide ball miler, because stainless steel ball miler is harder. And the last but not least is to conduct the experiment in the minimal air movement room, closed room, because the product is in powder and it also fine, so it easy to loss to surrounding. So just be careful during the transferring the powder from the balance into the bottle for the sonication especially. And in preparation of ink catalyst, the endographene required is 5 milligram. So it means that if lost even though small value amount, it can also affect the result later. So that's all for my presentation this time. Thank you for watching.